Okay, continue with our lesson. So we're going to solve for x. And then these, again, our variable is in an exponent. So we're going to have to isolate the base on that exponent. And then to get rid of an exponent, you're going to take the log base of whatever base to both sides. All right, so let's continue here. Let me zoom in. So let's isolate the exponent and its base. So the 94's got to go. So I'm going to subtract 94. And I'm left with 5 to the 1.2, 5, times 1.2 to the power of 3x minus 2 is equal to 100 minus 94, which is 6. Then I'm going to divide both sides by 5. And I get 1.2 to the power of 3x minus 2 is equal to 6/5. So I've isolated the base and its exponent. The base is 1.2, so to get rid of the exponent, again, I'm going to take the log base 1.2 of both sides. And so on the left-hand side, I'm just left with the exponent. So it's no longer an exponent. It's just 3x minus 2. And log base 1.2 of 6/5 using the change of base formula is going to be the log of 6/5 divided by the log of 1.2. And then I am going to add 2 to both sides. And so I'm going to be left with 3x is equal to the log of 6/5 divided by the log of 1.2 plus 2. And then to divide x, I already said it. The 3 and the x are multiplying, so to get rid of the 3, I'm going to divide both sides by 3. And so I'm going to be left with x is equal to the log of 6/5 divided by the log of 1.2 plus 2, all of that divided by 3. And if we don't want to think and just use our calculator, what happened to my calculator? It's still here. So I don't want to think, so I'm going to put all of this in the calculator as is. So it's going to be the log of 6 divided by 5. Then I'm going to close it. Divided by the log of 1.2 plus 2. And so all of that, so to make sure it's all of that, I'm going to put some parentheses there, divided by 3. And it simplifies to 1. So that's this problem right here. Next one. I have 5 to the 3x is equal to 5 to the 1 minus 2x. Well, if you notice, I have the same base on both sides. So 5 to that 3x is equal to 5 to the 1 minus 2x. Well, since I have the same base, a shortcut would be, well, since I have the same base, my exponents must be equal to each other. Shortcut, same base, therefore exponents should equal each other. And so literally we can just do 3x is equal to 1 minus 2x and solve for x. So we would add 2x to both sides. And we would get 5x is equal to 1. Divide both sides by 5. And we get x is equal to 1/5. Now let's say we didn't see that quite shortcut. So we could still do the same process. Since I do not have, since my variable is in the exponent, in order to get rid of the exponent, I'm going to take the log base 5 of both sides. So log base 5 of both sides. Shucks. I'm going to take the log base 5 of both sides. So I had, on the left hand side, I have 5 to the 3x. And I had 5 to the 1 minus 2x. And again, I have it on the cloud for a little while. But this is asking you 5 to what power gives me 5 to the 3x? Well, the answer is 3x. And this is asking 5 to what power gives me 5 to the 1 minus 2x? Well, the answer is 1 minus 2x. And you're left with the same thing right there. That's number 6. Number 7. 9 to the 2x is equal to 27 to the 1 minus x. Okay, so here, a nice little shortcut to see is that the 9, I can rewrite it as 3 squared. And then still to the 2x is equal to, and the 27, I can rewrite it as 3 cubed to the power of 1 minus x. And since here again the bases are the same, I'm going to write that down. Since bases are the same, sorry for the background noise, exponents should equal each other. So then I'm going to have 2 times 2x is equal to 3 times 1 minus x. And so this is going to be 4x is equal to, let me distribute the 3, times 1 is 3. 3 times minus x is minus 3x. Then we just add 3x to both sides. And I get 7x is equal to 3. Divide both sides by 7. And we get x is equal to 3/7, which is approximately 0.43. Oops. Number 8. Hang tight. Okay, number 8. 9.5 e to the 0.005x is equal to 19. So the base and its exponent, which is the e and the 0.005x, are not by themselves. We need to get rid of that 9.5. It's multiplying, so we're going to divide. And so we're left with e to the 0.005x is equal to 19 divided by 9.5, which if you do it on your calculator is 2. And so again, my exponent has the variable in it, and to get rid of an exponent, you're going to take the log given the base that you have. Well, the base is e. So this log base e has a special name. It's the ln. So we're going to take the ln of both sides. ln of e to the 0.005x is equal to the ln of 2. And again, ln and e are inverses of each other, or you can say e to what power gives you e to the 0.005x? Well, it is 0.05x. 0.005x is equal to the ln of 2. Divide both sides by 0.05. And this is your exact answer for x. And if you do that in your calculator, it's approximately 138.63. Number 9. ln of x plus ln of parentheses 3x minus 1 close parentheses is equal to ln of 10. So here, before we can take, so here we have ln's for once now. And again, in order to in order to get rid of logarithms, we can exponentiate both sides. But before we do that, we have to combine these. So we're going to need to combine. So when you have two logarithms with the same base, which in this case is e, and you're adding them, you can combine them by writing them as a multiplication. This is going to be the ln of x times 3x minus 1 is equal to the ln of 10. So this is step 1. So which step 1 am I talking about? Right over here. So step 1 is isolate the logarithmic expression on one side of the equation. You may need to apply properties of logarithms. Step 2 is to exponentiate each side of the equation with the same base as the logarithm. Then apply the inverse property for step 3. And then check your answer. We'll solve and check your answer. Okay, so let me continue here. Alright, so step 2. We're going to exponentiate. So my base is, the base is e. So I'm going to do e to the ln of x parentheses 3x minus 1 is equal to e to the ln of 10. And again, on the left-hand side, the e and the ln are inverses of each other. So on the left-hand side, I'm just going to be left with x parentheses 3x minus 1 is equal to 10. And so using the distributive property, we're going to have 3x squared minus x is equal to 10. And so it's a parabola. I'm going to subtract 10 from both sides, so I can set it equal to 0. And I have 3x squared minus x minus 10 is equal to 0. And we can solve using quadratic, but this one is factorable. The 3 isn't bad at all. This is 3x times x to get me the 3x squared. And then 10 isn't too bad. It's 1 and 10 or 2 and 5. the 5 and the 2 go here, and a minus goes here and a plus goes here. So I have 3x, and if I FOIL it, I will go and get 3x squared minus x minus 10. And once I factor it, and I set each factor equal to 0, and if I subtract 5 and divide by 3, I get negative 5/3. And here on this one, if I just add 2 to both sides, I get 2. So step 2, let me go back to the steps here. Apply the inverse property. So this is the inverse property right here that we did. This is step 3 right here. And then step 4 is to just solve for x, and we need to check it. So let's do the check here. So the original problem was the ln of x plus the ln of 3x minus 1 is equal to the ln of 10. So we can check, we need to check the negative 5/3. So x equal to negative 5/3. So it's going to be ln of negative 5/3 plus ln of 3 times negative 5/3 minus 1. We want to know if it's going to be equal to the ln of 10. All right, so here, I'm going to do, let's see, ln of negative 5/3, and it told me that it's already an error right there. So it doesn't work. I'm going to stop right there. So this one right here does not work. So it doesn't work. Now let's check the next one. So the next one that I need to check is going to be 2. So x is equal to 2. So it's going to be the ln of 2 plus the ln of 2 times, 3 times 2. 3 times 2 minus 1. And I want to know if it's going to be equal to the ln of 10. So here I go. So it's going to be ln of 2 plus the ln of 3 times 2 minus 1. And I get that answer. And I need to see if it's going to be the same as the ln of 10. And it is. So x equal 2 works. All right. Now, last one, number 10. So 3 log base 2 of 3x is equal to 1. So I need to solve for this logarithm. For this x, it's in a logarithm. I need to isolate it first, so I'm going to divide both sides by 3. And so I'm going to get log base 2 of 3x is equal to 1/3. Okay, so here on this one, hang tight. Okay, sorry about that interruption. So I have log base 2 of 3x is equal to a third. Okay, so we've already done step 1. We've isolated the logarithm. So step 2 is we're going to exponentiate both sides with the base. So the base is 2. So this is going to be 2 to the log base 2 of 3x is equal to 2 to the 1/3. And on the left hand side, we're just left with 3x is equal to 2 to the 1/3. And again, the reason why we're left with 3x is we're using that property that's listed in your notes on the previous page. And then we're just going to divide both sides by 3. So x is exactly equal to 2 to the 1/3. I wanted to use black. So x is exactly equal to 2 to the 1/3 divided by 3. I've erased that one as well. And you can get the decimal approximation in your answer. But we can check our work. So we need to check it. So it's going to be 3 log base 2 of 3 times 2 to the 1/3 divided by 3 is equal to 1. So let's do parentheses. So this is, so I have actually another parentheses here if I were to do it here. So I'm going to have 3 log, so this 3 and this 3 simplify to 1. So 3 log of 2 to the 1/3 is equal to 1. And actually, with the calculator, I didn't have to really simplify that. So let's see. Let me do 3 log base 2 of 3x. So it's going to be 3 times, I'm going to use the change of base formula. It's going to be the log of 3 times, and what was x? X was 2 to the power of 1/3 no, not there, hang tight. I still need some parentheses because I need to divide it. Divided by 3, that's what I need. So coming up here, 3 times the log of 3 times x, and then I need to divide it by the log of 2. And again, that's because I'm using the change of base formula, and I do in fact get 1. So here, let me go back and write what I actually did since I didn't want to simplify. So here on this one, hang tight. I take out the big eraser here. So using change of base formula, this is going to be 3 log base 2 of 3x is equal to 1 is going to be 3 log of 3x over the log of 2 is equal to 1. And so in the calculator I put 3 times the log of 3 times 2 to the 1/3 over 3, and then over the log of 2. And I did get, in fact, get 1. So this is my exact answer. You can get a decimal approximation. All right. Next one. Number 11 here. So the equation y is equal to 2 minus log of 100 minus x in parentheses divided by 0.42 can be used to calculate the number of years y required for x% of the robin population to die. Find the percentage of the robins that had died after 2 years. So the years is y, and x is going to be the percent. And we will need to find the percentage. So we want to find the percentage that have died after 2 years. So the 2 is going to be our y. So let's substitute it in. So 2 is equal to 2 minus the log of 100 minus x, all of that divided by 0.42. So we need to get the logarithm by itself, and eventually we're going to exponentiate using the log, using the base, understood 10. Okay, but first we got to clean it up. So we have to multiply both sides by 0.42. And if you do that in your calculator, you're going to get 0.84. And on the right-hand side, you're left with 2 minus the log of 100 minus x. Then we're going to subtract 2 from both sides. And so 0.84 minus 2, if you do it on your calculator, is negative 1.16. Is equal to the negative log of 100 minus x. The log is still not by itself. That negative in front of it is an understood 1 being multiplied. So to get rid of it, you're going to divide. And so you're left with 1.16 is equal to the log of 100 minus x. So let me write it down here. To get rid of log, exponentiate both sides using the given base. Well, the given base is an understood 10. Okay, so how does that look like? So I'm going to do 10 to the 1.16 is equal to 10 to the log of 100 minus x. On the left-hand side, I still have 10 to the 1.16, but on the right-hand side, again, I'm just going to be left with 100 minus x. So if you want to solve for x, you're going to get rid of the 100. And so 10 to the 1.16 is some number, but I'll let the calculator calculate it. 10 to the 1.16 minus 100 is equal to negative x. To get rid of that negative, I'm going to divide everything by a negative. And so this is my answer for x. I'll just put it over here. X is equal to 10 to the 1.16 minus 100. And my answer, I'm going to get the opposite. So let's see. Ten to the power of 1.16 minus 100. I'm just going to get my answer. And then it's the opposite, so it's a positive 85. Well, what the heck? I'm going to go ahead and put here the parentheses, the fact that I'm going to divide by a negative 1. And so I get 85.546. Or about 85%. So in 2 years, we'll have 85% of the robins that had died after 2 years. Number 12. We have, oh, it's not gonna let me zoom in. Okay, so the log base 5 of x plus 1 plus the log base 5 of x minus 1 is equal to the log base 5 of 15. So awesome thing that we all have the same base, which is 5. And so on the left hand side, again, adding logarithms, you can combine them as a multiplication. So it's the log base 5, technically, of x plus 1 times x minus 1 is equal to the log base 5 of 15. And so exponentiate both sides using base 5. And that 5 again is because I have those 5s there. Okay, so it's going to be 5 to the power of log base 5 of x plus 1 times x minus 1 is equal to 5 to the log base 5 of 15. So on the left hand side, using our properties, is just going to be x plus 1 times x minus 1. And on the right hand side is just 15. So if we FOIL this out, it will be x squared minus an x plus an x simplifies to 0. Plus 1 times minus 1 is minus 1 is equal to 15. I'm going to solve for x by adding 1 to both sides. And I get x squared is equal to 16. Take the square root of both sides. And I get x is equal to positive and negative 4. So we need to check. And so we have log base 5 of, so let's check the 4 here. Log base 5 of 4 plus 1 plus log base 5 of 4 minus 1 is equal to the log base 5 of 15. Oops. Where did it go? Well, without using the calculator, log base 5 of 4 plus 1 is 5. Plus log base 5, this 5 should be on the outside. Let me fix this. Log base 5 of 3 is equal to log base 5 of 15. Well, log base 5 of 5 times 3 using our properties of logarithms is going to be log base 5 of 15, so it works. So that's one way of checking it. You can also check it with your calculator. So x equal to 4 works. Now we need to check x equal to negative 4. So it's going to be log base 5 of negative 4 plus 1 plus log of negative 4 minus 1 is equal to the log base 5 of 15. Well, this is going to be the log base 5 of negative 3, and we can never take the logarithms of negative numbers. So that's not possible. Therefore, that's not possible. If you were to do it in your calculator, you would get